Unit 2, actually, it says Unit 1, but it's Unit 2, Solving Proportions is the topic. And what we've done so far is we have been solving equations. We've went from two-step equations. This would be an example. We've gone to multi-step equations, where we had to simplify one or both sides of the equal sign, and then make it an equation like that one, which is a two-step equation. And then finally, what we ended with is where the variable appears on both sides of the equal sign, and we needed to solve. We also discussed the distributive property, which when a number is right in front of the parentheses, we will distribute and then solve. So the 3 times the a plus the 3 times the 4. So we'd have 3a plus 12 equals 2, and then we would go from there. All right, so with proportions, let's go through the steps to solve them first. So the first thing we would do when we have a proportion, now all a proportion is it's two ratios that are equal. So for example, here they have 4 over 3, or 4 is to 3, equals x is to 6. And that's a proportion. All a proportion is two ratios that are equal. So the first thing to do when we're solving proportions is we cross multiply. And we'll discuss what that is in detail in just a moment. So we cross multiply. So to cross multiply, if I have a over b equals c over d, to cross multiply, just as the name implies, we multiply those two together, and that's equal to the multiplication of those two together. If two ratios are equal, this is always going to be true. So if two ratios are equal, if I have a proportion, then a times d has to be equal to c times b. It has to be. An example of that would be if I have 2/3 being equal to 4/6. Now if I reduce 4/6, I get 2/3. We can see that's true. But how about if we cross multiply? Well, 2 times 6, is that equal to 3 times 4? And it is. Okay, so that's why that works. The second step we do is we distribute. So if we have any parentheses, we distribute if necessary. We won't have parentheses all the time. And finally, the third step, we solve it. And remember, we can always check it to see if we did it correctly. So what I'm going to do, I'm going to go through most of the odd ones here as time permits and give you some examples of this. All right, so number one, we definitely have a proportion. We have two equal ratios. Now we're going to cross multiply. Now I like to multiply the two of them that are crossing from each other. I like to multiply the one that has a variable first, and then multiply these two. So 3 times x is equal to the 4 times 6. 3 times x is just simply 3x, and that's equal to 24. Now, I'm not going to show all the steps with this that we've had in the past, just because that's what we've been doing in the past. Here, they're multiplying by 3, so I would divide both sides by 3, and we get x is equal to 8. And for this one, let's check it. So our check would be, is 4 over 3 equal to 8 over 6? Because we said x was 8, right? Well, let's cross multiply. Is 3 times 8 equal to 4 times 6? And it is. 24 is equal to 24. Let's take a look at number 3. Now I'm going to erase some of this just so I can make this a little bigger, so we can see it a little better. And we're going to remember our steps up here. We're going to cross multiply, distribute if necessary, and then finally solve it. Okay? So let's take a look at number 3. Get a little bigger. There we go. All Right, so we definitely have a proportion here, don't we? Now, no matter which way I cross multiply first, I'm still going to have a variable. So here it really doesn't make a difference what I do first. So I'll do this first. 2 times y is simply 2y. Now here's the key thing. This is the real critical thing in this section. I cannot, so I'm going to write this down. I can't emphasize that. I cannot just take and do this, where I take 5 times y minus 3. Because in this situation, if you're looking at order of operations, I'm just taking 5 times y. And that's not what this is saying. This is one value up here. So this might be a part that you might want to pause and re-listen to after I get done with number 3, but I cannot just do that. Whenever you're taking a number times another value that's either above the fraction bar or below it, I have to use parentheses. I have to do this because it's 5 times, you're taking 5 times this whole value. If I do this right here, I'm just taking 5 times y, and I definitely can't do that. I'm going to put that in red, highlight. We cannot just use that raised dot. I have to use parentheses. So I'm going to take the 5 parentheses y minus 3. That is what it looks like. Now I distribute, because we have parentheses, right? So I have 2y is equal to, let's see, distribute the number that's right in front. So 5 times y is 5y. 5 times a negative 3, right? That's a negative 3, is a negative 15. And now it becomes an equation where I have the variable on both sides. And for all these, I'm not going to go through each and every step. I will review this now. All I have on the left side of the equal sign is the y term, so I definitely want to pick on this 5y. And when you pick on something, what do you add or subtract? You're going to ask yourself, what can I add or subtract to it to cancel it out? Well, I'd subtract 5y for both sides. Remember, what you do to one side, you do to the other. So 5y minus 5y definitely cancels them out. So what do I have? Let's see, 2 minus 5 is a negative 3y is equal to that negative 15. Divide both sides by a negative 3, we get y equals 5. And then we could check that to make sure that's the case. I think I will do one more check. So y is 5. So I'd have 5 minus 3 over 2. We're checking to see if that's equal to 5 over the 5, right? So let's see, 5 minus 3 is 2. So I have 2 over 2. Is that equal to 5 over 5? Well, if I cross multiply, is 2 times 5 equal to 2 times 5? Yes, it is. 10 is equal to 10. Okay, let's take a look at number 1 here. These are just practice problems. So again, I'm going to make this a little bigger. And all these are very similar, so I'm only going to have to probably go over so many of them because it's going to be a little bit redundant if I keep on going through them. But remember, you can pause and replay it. All right, so I'm going to cross multiply. So I have 8 times x is 8x equals 3 times, parentheses, remember, x plus 10. Don't just use that raised dot. So I have 3 parentheses x plus 10. Distribute, because I have parentheses, so 3 times x is 3x. 3 times a positive 10 is a positive 30. All I have left is x. All I have on the left side of the equal sign is an x term, so we definitely want to pick on the 3x.
Good morning, South-Hearted Tigers. If there is anyone in the building that has
really
brought flu shot consent form signed for your parents, and you have not received a flu shot yet today,
so what could I add or subtract
Thank you.
to 3x to cancel it out? Well, I'd subtract 3x. Because we would agree 3x minus 3x cancels. All right, 8x minus 3x is 5x equals to 30. They're multiplying by 5. We divide by 5, and we get 6. and then we could check it. All right, let's continue forward. Number 3. Actually, I'm going to jump over number 3 because it's very, very similar to number 1. I just want to make sure we hit on the different types of problems. Let's go to number 5. This one's a little different because you have the, on both the top and the bottom, don't we? All right, so let's cross multiply. I could either go 3 times the a plus 1, or I could start with a 2 times a minus 3. It doesn't matter. So I'm going to go the 3 times, parentheses, a plus 1, equals the cross multiplication of the other 2, which is 2 times the a minus 3. Now here, I need to distribute on both sides of the equal sign. So 3 times a is 3a. 3 times a positive 1 is a positive 3. Here I have 2a, right? 2 times a. And then 2 times a negative 3 is a negative 6. Okay? Let's get all the a's on one side. Usually, it's easier to pick on the small one. Here I have a's on both sides, so I want to pick on the small one. That's the 2a. What could I add or subtract to it to cancel it out? Well, subtract 2a, because they cancel. So I have 1a, or simply a, plus 3 equals a negative 6. Now get a by itself. They're adding 3. We always do the opposite. So we'll subtract 3 from both sides. Make sure you take 3 away from it. And you have a negative 6 minus 3, negative 9. All right, let's take a look at number 7. Again, most of these from here on out are going to be very, very similar. We'll maybe do 1 or 2 more here. I'm just kind of glancing at them. Let's take a look at maybe number 15 here. And then we'll summarize. This is a little larger. Okay, there we go. All right, so again, I have a proportion. We need to cross multiply first. We've already said it doesn't matter if I go this way first or if I go that way first. I'll do the 3 times the 3u plus 7, always equal to the product of the other 2, equals 2 times the 4u plus 9. Distribute. So 3 times 3u is 9u. We got that by just multiplying 3 times 3. And then 3 times positive 7 is a positive 21, equals 8u. Then 2 times a positive 9 is a positive 18. All right, let's get all the variables on one side, pick on the small one. We would subtract 8u to cancel it. So we have to subtract 8u over here. And 9u minus 8u is 1u or u plus the 21 equals the positive 18. They're adding 21. We'll subtract 21 from both sides. Make sure you take it away from the other side. I'm emphasizing that also. 18 minus 21 is a negative 3. And that should check out. And we've gone over some examples on how you would check it. So we're taking this to the next step with this topic, which is solving proportions. We've already said that we started here, then we went to multi-step problems, and then finally variable on both sides, which can involve the distributive property, and then finally where we have proportions.